So on day 4, again, we have anybody know the name of this thing? Yeah, it is. It's a cubic. Nope, polynomial is the word. It is a cubic function. You are correct. All right. We term it by number of terms. This has 1, 2, 3, 4 terms. The plus and minus signs separate the. And there's always a minus sign here. So there's 1, 2, 3, 4 signs here. Generally, that's a plus sign on the front. Disappears. Okay. But if that was not there, that would mean I still have 4 terms. Okay. So what would we call it if you only have 3 terms? It's called a trinomial, okay? So, and then you have what we call a binomial, all right? So in this case here, we have 1, 2, and 3. 1 would be monomial, okay? So that would be 1, 2, and 3, and this is 4 or more, okay, by terms. So we call it by its degree or terms. What other name do we have other than cubic? Yeah, what's quintic mean? Quintic is 5. So what's the one between cubic and quintic? Quartic. Like quart. What's underneath cubic? Quadratic. So quadratic is the 2. Okay? So what we learned last time was our quadratics test today. All right? And then we have under quadratic, linear. And under the linear, constant is the one that we start with. A constant is just a number. So like 5 is a constant, okay? Know the names are useful. All right, now, how many solutions? 3, and there's why, because there's a what? Yeah, there you go. So we can go ahead and group the first 2, last 2, since it's a polynomial. It has 4 terms. Pull a negative x out, x squared, and you're left with what? X plus 4. Just like yesterday, we had an x plus 1. So I have an x plus 4 over here, so I have to pull out a what? A plus 1 for sure. You got to have a placeholder there. So when I yank out the x plus 4, it leaves me that negative x plus x squared plus 1. Now, that negative x squared, we can change that and pull out the what? The negative, and make that an x squared minus 1. And then what can you do with the x squared minus 1? Yep. Your whole goal is to bust this apart as far as you can, all right, until you have either quadratics that are prime, all right, that you can't factor, all right. So if you get to the quadratics of the prime or imaginary, when you do that, we're gonna have to use the quadratic formula to find those solutions if we need them. Okay. Graphing, we don't need imaginary solutions, but we will need the irrational if they are irrational. It's rare that we actually deal with those. We kind of, when our polynomial unit, we try to make all the answers be rational. All right, so let's go ahead and find our y-intercept. How do you find a y-intercept? Anytime? You have to plug in what? 0 for what? X. And as you guys know, hopefully you know it's the back end of our polynomial, because that's your constant. Okay? So it's just 4. I'm really plugging in 0. If you got this written in standard form, it's always going to be your back number back here, because everything else has an x in it, and those would all end up being 0. So 0, 4 is our y-intercept. Take each of these and set them equal to what? 0. I'm doing a little 0 product property. Solve it. And hopefully this, when you get this right here, that you know how to reverse it and create those into factors. is just as important as to take your solutions and write them into factors as well. Okay, you're going to do that at the bottom of the page here in just a minute. So I get done and I write my intercepts. And then you look for what? Look for multiplicities. Are there? Are there any multiplicities? Any multiplicities? No multiplicities. What do multiplicities do? If you're even, if you have an even multiplicity, then it will bounce. All right. If it's odd, it passes through. Okay. So in this case here, there are no multiplicities, so it's going to go through it. All right. End behavior. How do you find your end behavior? What I have been writing here every single time. Yeah, what's your leading term in this one? Negative x cubed. And so we're going to plug in the negative infinity here. So I get negative, 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 negative. 4 negatives give you a what? Positive. So as we go left, we go up. As we go right, we get negative, which means we're going down.
An emergency has been reported in this building. Please cease
So we're going to start here, finish here.
utilizing the
So it should look something like that.
fire exit stairway.
Well, let's graph it.
Use elevators. Repeat, do not use elevators.
-4, -1, +1, +4.
Attention. Attention. An
Start up,
emergency has been reported in this
finish down.
Please cease operations and leave the building utilizing the nearest
Up here, go through this,
fire exit
turn,
Do not
turn.
use elevators. Repeat, do not use elevators.
Even, odd, or neither. It's a neither. Just so you guys know, when we're dealing with polynomials, there's more neither than there are anything with symmetry. Okay, so there's no symmetry here.
Attention. An emergency has
Remember, that's y-axis symmetry for even,
Please cease
and this is rotational symmetry
building
for odd.
using the nearest
Means it's got to go through 0 to 0, so it's not doing that.
Do not use elevators. Repeat,
All right,
do not use elevators.
going down here. Got to write these factors. Now, this one, since it's 2/3, it's a little bit different. Do not write it as x minus 2/3. I do not want it written as a fraction like that.
Reported in this building.
Multiply by 3 first.
Operations and leave the building utilizing
Then subtract your 2.
the fire exit stairway.
That's your factor.
Elevators.
This is your solution.
Do not use
I'm
elevators.
trying to write our factors down here. What's this factor going to be? X plus 1 is correct.
Attention.
But what's that mean?
An emergency has been reported in this
There's 2 of them.
Please cease operations and leave the building.
What about that one?
Exit or fire exit stairway.
X equals 0. What would that end up being?
Repeat, do not use elevators.
Would that be like x minus 0? Do we ever write a factor like that? No, it's really just single x. So there's going to be an x on the end here. That is your factored form.
Attention, an emergency has been reported in this building. Please cease operations and leave the building.
You can put parentheses around if you want.
Exit or fire exit stairway.
You can. It doesn't matter. It's not necessary.
May I have your attention, please?
We're all good fans. Yeah, must multiply two of these together. Now, it doesn't matter which two you multiply together. I generally just start with this first group right here. Okay? And so our first term is 3x squared. Then we're on the outside, we're getting positive 3x minus 2x, which gives me a plus x, then minus 2. Then you're going to multiply the x plus 1. Now, there's two ways you can go about doing this. All right? You can, and I'll show you, maybe this method might help you out a little bit to shorten up your work a little bit here. It's taking the back one right here, just taking this x and distributing the x to each of these. So x times 3x squared is 3x cubed. Then you multiply the x to the x. And finally, the 2. Then take the 1 and multiply each of those things as well. Distribute the 1. Now I'm going to write this one underneath and make sure my columns are the x squared, the x. So yesterday what we did, we took the 3x squared and multiplied each of these, and we ended up being 3x squared plus x squared. And then we took the next one, which is the net x, and got x squared plus x. And then we took the last one, which is the negative 2, and did negative 2x minus 2. This one stacks 3. This one only stacks 2. So you have to decide how you want to do that. I don't care if you multiply the back one to the front one or the front one to the back one. You're still going to get the 3x cubed plus 4x squared minus minus x minus 2. That's supposed to be a 3 right there. I'm messed up here. There's supposed to be a 3 there. So this one stacks again. I don't know. It's a little bit cleaner to me. It's more and more efficient, but it doesn't matter. When you get done with this, there's an x in the back, and you have an f of x in the front. And what will you do with the x? Yeah. When you distribute that, that's just going to be 3x to the fourth plus 4x cubed minus x squared minus 2x. Here is your standard form. What do we call that one? Yeah. Yeah, it's a quartic polynomial. In quartics here, remember, when we're talking about a quartic, it's either going to go up, up, or down, down. And since this leading coefficient is positive, it will go up, up. So we know that. The other thing we know is all my intercepts. We know all our solutions are right here. So we could end up graphing this. We know at -1, it's going to bounce at this one. We know here we have 2/3. Here's 2/3. Here we're going to cross at 0, 0. We're going up, up. So you could actually graph this, and it would look something like that. If you want to make it more pronounced, it comes down here, it bounces, passes through, passes through. So, remember, our goal is we're probably going to give you, again, we can give you this graph, and then we ask you to write it in the standard form. Okay? So if you got one that bounces on there, you want to make it not 4 times, you want to make it as small as you can. So you'd want to make it x squared, not x to the 4th. Okay? Questions? We get better with these. Again, as I said, I would step these up a little bit and they get a little bit harder as you go along. I did add, in this case here, an x to the 0 in this case, and then I gave you a fraction that you dealt with. We did a multiplicity yesterday, so you know how to deal with multiplicities. So, all right.